Well, hey there, kiddos. Welcome to your next video on factoring. This is just going to be called Factoring Day 1. All we're going to do today is we're going to factor trinomials where the first term is going to be just an x squared. There won't be a coefficient in front of that. And so this is actually a fairly simple process whenever the x squared doesn't have a number in front. When it's just x squared, there's no coefficient. So we're going to go through this pretty fast, and then tomorrow you will practice this. So standard form of a quadratic looks like this. It's always ax squared plus bx plus c. The thing you need to get from this is that the variables go in decreasing order from x squared to x to no x. And so that's what I want you to know. In order to factor, our quadratic needs to be in that form. If it's not x squared, then x, then a number, we need to rewrite it so that it is, because then it makes it easier to factor. So what we're going to do first for this problem, x squared plus 9x plus 18, is we're going to label what our a, b, and c are based on this form. And then we're going to find out what a times c equals, and then we're going to go from there. So here's how this works. Remember, there's an invisible 1 in front of your x squared here, so a is 1, b equals 9, and c equals 18. So the first thing we're going to do is multiply a times c, because we got to get some air conditioning up in here, because even though it's February in Texas, it's hot. So we got to get some AC going. So we're going to multiply a times c, which happens to be 18 for this problem. And what we want to do is we're going to make a table here to list out all of the factors of 18. Our goal when we do this is to get the factors of 18 that multiply to make 18, that when I add them will make this number 9 right here in the middle. So they will make this number 9. So I'm going to list factors of 18. So there's 1 and 18, there's 2 and 9, there's 3 and 6, and that's it. So if I go to add them together, 1 plus 18, if I add them, makes 19. So these are not my factors because I need it to make 9. 2 plus 9 when I add make 11, so that's not it. But if I do 3 plus 6, those equal 9. So these are my two numbers that split to make this 9. So when I go to factor this, these become my two factors. And so they're both positive, 3 and 6, so my factors become x plus 3 and x plus 6. And if I went and used the box method or double distributive property and I multiplied these two polynomials together, I would get x squared plus 9x plus 18 as my final answer. So let's do another one. Let's do this one right here, this number 2. I've got x squared minus x minus 56. So list a, b, and c first. So I've got a is 1, b is negative 1, and c is negative 56. So I'm going to multiply a times c first, which makes negative 56. And I'm going to have to figure out factors of negative 56. So this becomes a longer list because now I have to list them both. I have to list a positive and a negative so that I can make that a negative number. And so I'm going to have negative 1 and 56. And then I'm going to have 1 and negative 56. So this is going to be the one where I have to write a whole bunch. I'm going to have to repeat them. And so I have negative 2 and 28. Then I have 2 and negative 28. And then 3 doesn't go into it, but I have negative 4 and 14. And then I have 4 and negative 14. And then I get all the way down here. 5, 6 don't work, but 7 does. So I have negative 7 and 8. And then I have 7 and negative 8. And so now I've got to figure out which one of these add up to make this number right here. So I've got to split this number into its two terms. Well, negative 1 and 56 doesn't make it. 1 and negative 56 does not equal negative 1. Neither do these or these. But then I get down here, negative 7 plus 8 becomes positive 1. So that's not it, but 7 plus negative 8 makes my negative 1. So here are my two factors. I have 7 and negative 8. So if I were going to write down my factors for this trinomial, they would be x plus 7 and x minus 8. So now when we get down here, they now ask us to use the box method, and we're going to go ahead and do that so you can see that it works out to exactly what I showed you, and then you can just use that shortcut every time. So I'm only going to do the box with one of these so you can see what happens, and we're going to do Let's do number 8 down here. So I have x squared plus 11x plus 28. Remember, that's a 1x squared. So I'm going to have to do a times c. So 1 times 28 makes my 28. So let's list our factors. I have 1 and 28. I have 2 and 14. I have 4 times 7. And that's it. So now let's add them. Well, these make 29. These two make 16, and when I add these two, I get 11. So the two that I need are this 4 and this 7. So what I'm going to do is split this into 4x and 7x. So I'm splitting this 11x into the 4 and the 7 that I got from here, and they both have an x because when I add them up, they need to have an x. So now I have my 4 terms. So this is really like saying I have x squared plus 4x plus 7x plus 28. So now I have 4 terms I can fill in the box with. So I got to make a little bit of room here. These are in the way. So I'm going to fill in my box with my 4 terms. So I have x squared plus 4x plus 7x plus 28. So I'm going to go do the greatest common factor for each little box, each row and each column, and then I'm going to write down what I have. So the only thing that these two x squared and 4x have in common is an x. And then my greatest common factor for 7x and 28 is just 7, because 7 is the biggest number that goes into both of them. Then for this row, x squared and 7x, the only thing they have in common is an x. And then for this row, 4x and 28, the biggest number that goes into both of those is 4. And so what I end up with as my factors are x plus 4 and x plus 7. And so you see that these two numbers make my factors. So there's no reason to go draw the box and go through all of that. If you can find the two numbers, as long as your coefficient in front of the x squared is a 1, well, as long as you can find the two numbers that multiply to make your 28 and add to make your middle number, then you have it. You're done. So let's look at a couple of application problems so that we can see how this works no matter what. So number 9, I have an area of a solar panel that's given by the trinomial x squared plus 7x plus 12. The height of the solar panel is x plus 3. We want the expression for the length of the panel. What they are asking you to do is they are asking you to factor this area polynomial to get the two factors. One of those factors should be x plus 3. The other factor is the one that we're looking for. So I'm going to have to multiply a times c first. I get 12. So we're going to list out factors of 12, and I need my two factors to add up to 7. So my factors are 1 and 12, 2 and 6, 3 and 4. So let's add them. Well, these make 13. These make 8. These make 7. Well, these two are not the ones I want. These are. So my 7 here splits into these two numbers, 3 and 4. So my factors become x plus 3 and x plus 4. Well, like I said, one of my factors is x plus 3. This is not the one I want. The one they're asking me about is the x plus 4. So the length of the panel is x plus 4. It's just the other factor. So number 10 here says a farmer plans to replace the fence of his rectangular horse pen. He wants to add a fence that divides the pen in half by connecting the centers of the longer sides, as shown in the diagram. Now your diagram is not pretty like mine because it's just black and white, but that's what it looks like. The area of the entire pen is x squared plus 11x plus 28. And there's your one in the front. It says to factor the trinomial. Well, we did factor this trinomial already. We factored it right here on number 8. That is the exact same polynomial, x squared plus 11x plus 28. And I got that my factors were x plus 4 and x plus 7. We already did this one. There's no reason to do it again. Well, now that I know my two factors, the question asks, so problem B here just asks us to write a polynomial in simplified form that represents the total amount of fencing needed. Well, the total amount of fencing, that's a perimeter question. So now they are asking for the perimeter of how much fencing he needs. So now the dimensions of his horse pen they've just given us are x plus 7 and x plus 4. We found those when we factored. And so if I label all 4 sides, I'll add up my x's. So I have 1, 2, 3, 4 x's. And then I have 4 plus 4 makes 8. 7 plus 7 makes 14. And when I add 8 and 14, I get 22. So this is the total amount of fencing that he needs. So there is factoring at least whenever a equals 1. So whenever the x squared does not have a coefficient, that's how we factor. You find the two numbers, you write down your two factors, wipe your hands, call it done. So we will do this when you come to class tomorrow. I will see you then.